Hi everyone, welcome back. We continue on this. Lastly, we learned about this shift class, and today we are gonna learn about this ORB. ORB stands for oriented fast and the rotated brief. I think here is wrong. If there is a detailed explanation also in here, which is in the OpenCV documentation, you can find this one also. In here it says also oriented fast and rotated brief. Actually, the importance of this ORB detection is this is focusing into the rotation invariance, and it does not really care about scale invariance. So in the case of you are comparing the features, which is both images and the objects are the similar scales, then in that case maybe it can be used to use ORB. Also, if the rotation is important, maybe the object rotationary always changing, so in that case ORB is gonna be a good option. So for this video, first of all, we are gonna compare ORB with the other feature type detection which we already learned. In here I already updated our table, and you can also stop and see detail in here. And we already learned this until shift, and this ORB is added newly, and it's very similar in the type case. It's also key point detector. Also it's giving a descriptor for each detected key point like the most of others. And scale invariant, the only disadvantage of ORB is that it is not scale invariant. So in the case of if you are using different kind of image scales and you need to compare them, then in that case maybe ORB is not gonna be a good option. But rotation invariant, maybe comparing to the others, this is the fastest and the best one we can say, because the focus of ORB is the rotation. In also in the name we can understand it says rotated brief. Okay. And feature type, this is binary robust features similar to the others. For example, brisk also is like that, and this also Akaze also like that. So this also binary robust features as the feature type. Okay. Descriptor support, as we said in here, yes, and it's also like the others binary descriptors it is using. Okay. For these descriptors in these videos we are not focusing much, but at the end we are gonna make a descriptor video and we are gonna try to compare the key points we have detected. Okay, this was the code from the previous video. First of all, in this video, as we did previously also, we are just gonna check the class initialization and see how it looks like. And in the next video we are gonna focus to the parameters, focus to these member functions and the change of these, how affecting the output. Okay. And this is from the previous video. We were checking the shift and it was working like this. So these are the detected points, and here all we need to do is just searching this shift and changing with ORB and replace all. So we change this also, maybe the naming should be also ORB. Oops, smaller letters, and replace all. So yeah, all is done. We are basically just creating this with the initial parameters, and here it is taking many parameters. These are the default parameters we see here, default values, but all these can be updated after the object is created. We can update like orb.set or something like that. In here we have the member functions for set and the get, so we can set the desired values, and we can I'm gonna explain in the next video how they are working and how they are meaning. And here we are defining our key points and descriptors. So we are just detecting, here is only giving us the key points, and if you do not need descriptors, you don't need to do this line step. You can skip this and you can just draw the key points at the end, which is we are currently doing. And for the descriptors, if you need a compare case, in that case you need also this line. Okay, we can run this and see how it looks like. Okay, so previously for the shift default values we were detecting 76 key points, and now we get 378, which is much. Let me make it bigger. You see here many yellows are the detected key points. Yeah, it's detecting here also some feature detection classes defaultly detecting these things because they are actually also edge but some is eliminating with the default values. Anyway, in the next video we are gonna try to maybe remove these noisy detections. Also we are gonna check the member functions, check the parameters of the ORB. Okay, and I'm done for this video. Thanks for watching. See you in the next videos.